Let me get this out of the way. One more. All right, here we go. So to start our discussion on ionic substances, we're going to start talking about ions. Because what would be your best guess of what an ionic bond is? It's a bond between ions. What a great definition. It's almost like they named it that way on purpose. All right. So it's extremely important that you understand what an ion is. An ion is a charged particle. Now, to us, an ion is an atom that has lost or gained electrons. Can someone tell me the overall charge of an electron? Okay, well, not a number. Sorry. Is it positive or negative? That's all I'm looking for. It's negative. So this really does mess with a few kids' mind. The thing we're going to gain will make us negative, and if we lose it, it will make us positive. Are you okay with that? Just wrapping that around your head real fast. It seems a little bit backwards because we're used to something gaining being a good thing or whatever. If you look at it like gaining weight, then you'll understand. All right, so remember yesterday we defined metals, nonmetals, and metalloids. I want you to write this. Like, if I would recommend you just draw your own little periodic table and label column 1 and 2, but just know the following. Everything over here is metals, right? So everything from this crazy line that way are metals. Over here are nonmetals. Now, I want you to add something. Metals are losers. If you can memorize that for your whole life, just that metals are losers, move that out of the way if you're writing the red, then you'll be halfway through the battle of memorizing this. Nonmetals are gainers or stealers. That says stealers, not stakers. Whatever. All right. So if metals are losers, that makes them what overall? What charge? Positive. Metals always are positives. If nonmetals are always gaining or stealing these things, that makes them always a negative charge. Okay? Don't ever get them backwards. So first off, metals lose to become positive. Nonmetals gain to become negative. We all right with that? All right, the little bullets here, when atoms lose or gain electrons, they become ions. Cations are positive and are formed by elements on the left side of the periodic chart. Well, what's a fancy name for calling things on the left side of the periodic chart? Metals. I don't even know why it's typed that way, but whatever. Metals. Anions are negative and are formed by elements on the right side of the periodic chart. We have a name for those. Those are nonmetals. And how come we hardly ever talk about what happens to these, the metalloids? No, they react. They do react, but they go either direction. That's what makes them able to be metallic, meaning losers, and non-metallic, which means gainers. They can play whichever side they need to satisfy whatever the current demand is for their use. All right. Now, a simple way to remember cations are positive is to write the word. The charge is in the name. It's right there. Okay? Cations, positive, anions, negative. If you just think anti-ions or whatever, that might help you to think of something negative. All right, so an ionic bond can be defined as a bond between cations and anions. There's another way to define this. It's a bond between metals and non-metals.
So would iron oxide be
Iron oxide absolutely is an ionic bond because it has the iron metal, and the oxide is the non-metal oxygen. Oh, that's not going to work. Oh, it did work. No, it didn't work. Walk away, Tom. All right. You okay with that definition? All right, let's go back to this periodic table that you're going to draw. So it should look something like this, except for a lot prettier. You okay with that? I'm going to put some lines in here. I'll use my line tool so they're straighter. Okay, that was ugly, but whatever. Oh, thank you for being useless. That was to me. Sometimes I don't do my best. This is going to drive OCD people insane. Let's see. 1, 2, 3, 4, 5, 6. All right. Then just kind of have a staircase through here, whatever. And then I got to come up here. So this is family 1, right? This is family 2. We skip the transition metals for right now. Then you have family 3, yada yada. That's going to go all the way over to family number 8. All right. Okay, does that kind of look like a periodic table? You need to, thank you. What we drew this for is everything in family 1, they all have the same chemical properties, and that's because in the ionic bond, they always form ions of +1. Any guesses what family 2 would do? They would make ions of a +2 charge. Am I the only one that looks at the screen and sees like dark lines and then a million light gray lines? It is. Yeah, now I can't even look ever again. All right, then metals in family 3 sort of make a +3. So that would be aluminum for sure. Al would be a +3. Then sort of +4. And we're going to ignore. But those are just metals. Okay, anyone know what charges family 8s make? Family 8 does not make any charge because it's a noble gas. It doesn't want to lose or gain. Because when we say something's going to lose or gain, they're losing or gaining to become like a noble gas. Well, if they're already like a noble gas, they don't need to do anything. All right. Something in family 7, any guesses what it's going to do? It's going to gain 1, so it's going to become a -1. Something in family 6, -2. Something in family 5, -3. And then we have this family 4 could be a plus or -4. It just depends on what you're talking about. Okay, if you are okay with that, then this will make sense. For metals, charge equals family number. So it's in family 1, that's its charge. It's in family 2, that's its charge. Family 3, that's its charge. Family 4, that's its charge. After that, things get a little bit hairy, and we'll talk about those, but we don't need to this very second. All right, for a nonmetal, it's harder to just write, but the charge...
Teachers, we are ready for the students with the last name beginning A and B.
Get out of
The
here.
pictures taken.
Go
Please
fast.
send those students to the small gym.
Go fast.
That's letters A and B. Thank you.
Go fast. Run, cross-country runner.
Run.
His legs are longer than all of ours combined. And he's like, oh, I'll go as slow as possible. All right. Are we all right with that, sort of? So nonmetals, there's a lot of different ways to define it, but it is equal to their family number minus 8. Okay? You want me to write that? For nonmetals, charge equals family number minus 8.
One of those lines in your Y just goes black.
What's that?
Is one of the lines in the Y black? Or am I seeing it?
Yeah, that happens every once in a while. I have no control over that, so
Do you have any idea why it happened?
I have no idea. It's happened for millennia.
Why?
That was funny. I told a super funny joke in driver's ed yesterday, and neither one of them laughed, and one of them just thought I was stupid. I can't actually say it because this is being recorded, but it was dang funny. And then I had to like explain it for 10 minutes, and the girl was like, "That's just really not funny." I'm like, "You need to get out of the car right now." In the middle of Logan Canyon. She did. I was like, "Come on."
Was it the hey joke?
No, it's a little bit inappropriate, so just, if you're watching this on TV, don't be offended. It'll pick it up either way. It said there is no I in team unless you have an a-hole.
Oh, yeah.
Does anyone need me to draw that out? Because if you have an A that looks like, I'm not much of a block letter drawer, but I'm actually doing pretty good. If you have an a-hole right there, then you actually do have an I in team because there's an I right here. But the only way to have
That's just not funny.
it is dang funny. Sorry. We were talking about teamwork and moving on. If you're offended online, I apologize, but it's fun. The hey joke is very funny. It just takes a keen sense of humor to understand that. Thank you for reminding me how awesome that joke is. Okay, so for a nonmetal, the reason you subtract it from 8 is it wants to become 8, so the number that it will gain will be equal to the difference between them. Are you okay with that? All right, super not hard. Let's try some. So here you go. What's the charge of aluminum? Plus 3. All right, good answer. What's the charge of nitrogen?
Plus 4, 5?
No, it's a nonmetal. Minus 3. So, like your brain has to work the following way. I give you something, you say metal or non-metal, because that decides the number, right, or the value, and then it will definitely affect the value or the number also. I can't
Well,
talk.
why is nitrogen minus 3? It's
Because non-metals are losers. Nitrogen is a non-metal. It's in family 5. You subtract 8, that's negative 3.
oh.
All right, how about bromine? That one should be easy. Negative 1. How about Ca, calcium? Plus 2. All right, how about silicon? All right, look at the screen. It's tricky. It's a plus or minus 4. It can go both because it is a metalloid, meaning it has metallic and non-metallic properties, meaning it could lose 4 or it could gain 4. Either one is fine. All right. Now, depending on who a metalloid with, that will tell you whether it's behaving metallic or non-metallic. Like, well, I don't want to do that yet because that'll get confusing.
Well, if it's with a metal, then it's going to be aqueous and not.
Definitely. But sometimes when it's with a non-metal, it still behaves ionically. That's why I didn't want to go there. Whew. How was that? Yeah, good. All right. Okay, everyone, you okay with ions? They're not supposed to be mega difficult, but you have to understand them. All right? Ionic compounds such as NaCl are generally free metals and non-metals. That will be 95% of them in this class. The only exceptions really for us where we will have an ionic compound that does not have a metal in it is when we have the ammonium polyatomic ion. Does anyone know what that is? Yes.
4+.
NH4+. Okay, both of these are non-metallic, but they make a plus, which means they form an ion, so they can still form ionic bonds. Okay, that's pretty much your only exception. All right, now this is where we really get to write formulas, and it's very simple for ionic compounds. Because compounds are electrically neutral, one can determine the formula of the compound this way. The charge of the cation becomes the subscript of the anion. The charge of the anion becomes the cation. If these subscripts are not in lower whole number ratios, divide them by the greatest common factor. Now this might sound really confusing. Do you know what we called it last year, Windsor? Okay, good. This can all be boiled down to the drop and swap. Okay, the drop and swap. So this is how I would advise you to do this and go through every part of it now when it's easy so that when it's harder it's not. All right, so this was magnesium nitride. Let's do a different one. So like aluminum and oxygen. So the first thing you do is write the charges of the ions right up here. So you would look at your periodic table and you would find out aluminum is what charge?
13.
Plus 3. You would look at oxygen. You would know it's a non-metal, so it must be minus something, and it would be a minus 2 because it's in family 6. 6 minus 8 is minus 2. Then the drop and swap says that the charge of aluminum becomes the subscript for oxygen, and the charge for oxygen becomes the subscript for aluminum. Now, we never write negatives down there because we can't have -2 aluminum atoms. That makes a negative sense. See what I did there? I'm full of them. All right, so we would say the formula for aluminum oxide is Al2O3. Now, I want to show you why. Hold on. All right. All right, this won't be too hard. Can you guys see that? Let's just do some quick math here. There are 2 aluminum atoms in this molecule, right, or compound, correct? If one of them's a +3, what's the total amount of charge the aluminums contribute? 2 times 3 is +6. Well, that is a good-looking 6 right there. Woo! Mr. Redden will be proud of me right now. All right, now, there are 3 oxygens, and each one of them is a -2. So, What is the total charge the oxygen contributes to this molecule? -6. If I add these two together, what do I get? 0. In an ionic compound, and make sure you realize this is only for ionic compounds. In ionic compounds, they always add to 0. Always. If they don't, then you did it wrong. Now, it's important that you realize ionic compounds have different rules. All right. So, I'm looking here. Jesse, you played volleyball, right? Did you ever get a penalty kick for using your hands? No? Well, why not? You can't use your hands? Oh, I was soccer. Not really. How come in volleyball you don't get a penalty kick for using your hands?
Can you kick a volleyball? Is that against?
I'm pretty sure you can lightly kick it. Yeah, I'm pretty sure you can. But, now we're starting to argue silly things. You should know that the rules for soccer don't apply to the rules of volleyball. Does everybody know that? I'm going to substitute some chemistry words in here. The rules for ionic bonds do not equal the rules for covalent bonds. So later, we're not even going to talk about covalent today, but later on, don't try and force covalent to fit the model you established for ionic. You with me? Just as though you wouldn't give someone in volleyball a penalty kick because they use their hands, it's because the rules to volleyball are nowhere remotely close to the rules of soccer. You all right with that? Okay. I'm going to leave this up here while we just do a couple of examples. So, can you see that? I tried to print this morning and it just, I don't know, I must have sent it down to the office. So here we go. Using this chart, or you're looking at the periodic table, I want you to come up with the formula of the following. So lithium chloride, that's one. How about magnesium phosphide? See if you can figure out the formulas to both of these. Bless you. All right, who still needs time? Okay, my fault. I'll give you one more minute. All right, so here we go. Lithium chloride, the formula for lithium is Li, or the symbol, I should say. I'll say formula a lot, symbol, whatever. To me, chloride just means chlorine, so I put a Cl. What's the charge of lithium? It's a +1. Charge of chlorine is a -1. So if they're the same number, do I need to put anything down there? No. If these already add to 0, don't put anything down there. So LiCl is the correct answer for lithium. All right, magnesium phosphide. Magnesium is Mg. Phosphide might sound scary, but it just means it's phosphorus. So Mg is a +2 because it's in family 2. Phosphorus is in family 5, so that means it is a what? Not a plus. -3. So phosphorus is not considered a metalloid. Like it's the bottom left corner of it touches the staircase, but it's not really on the staircase. So it has Mg3p2. How many had them both right? Raise your hands. All right. We're going to do a little practice activity here in a minute, but I have to teach you a couple more things. Oh, yeah, we got plenty of time. All right. Endings. And this is not a comprehensive list. The problem with chemistry is everything works most of the time, but not all the time. Okay, if your thing that you have to write the formula for ends in IDE, that most of the time just means non-metal. Well, that doesn't look like means at all. Non-metal element. There are some exceptions. Hydroxide. And cyanide. I think those are the only 3. There might be more that we'll come up with here in a minute. That's ITE. So ATE or ITE, what have we already learned about those? All right. Polyatomic ion involving oxygen. Most of those, it's what it sounds like, the element, and then 3 oxygens. But that is a majority by like 52 to 48%. So if you notice, we don't really teach you a ton of rules about polyatomic ions. We will, but we'll say mostly just memorize them. All right, so if it ends in IDE, it's just the element. Like phosphide, that was just P. Chloride, that's C. Bromide, Br. Iodide, that's the I.
Teachers, we are ready for students with the last name beginning C and D to please go to the small gym for their picture. C and D. Thank you.
Goodbye, my friends. All right, the next thing we are going to talk about is what to do if it's not one you know. So what I mean by that, what's the charge of mercury? Look at the board, or look over here. Mercury is the blue one, number 80 down here, rightish, middle, lowerish. Hg. Here's the problem. Mercury doesn't have a specific charge. You're like, what? Well, mercury it's usually a +2 or a +4. depending on how it feels that day. All right, so the only way to know which one it is a Roman numeral. N-U-E-N-E-U. Roman numeral. All right, so when you see mercury, it's actually kind of nice. It'll be in the name. It'll be like mercury 2, they'll put a Roman numeral, oxide. Okay, that's a D. So what you would do is you would write the symbol for mercury, that is Hg, and then it's super nice. The Roman numeral tells you it's a +2. You don't have to think, you were told. And kids like that in high school. You think you want freedom until you get it, and then you don't know what to do with it. What's the charge of oxygen? It's IDE, right? So it's just oxygen. It's a -2. So I could put a 2 and a 2, but I don't need 2 because that already has a 0. So mercury 2 oxide would be MgO2. Or sorry, Hg. Oh, I blew everything about that. You'll know why, because here in a second. So that's mercury 2 oxide, but you could have mercury 4 oxide, and my brain was thinking ahead. So if you were paying attention, you should already know the answer to this one. All right, so mercury is Hg. Is it a +2 now? No, it's a +4 now because this told me oxygen still is a -2. So the instruction said to drop, so I had a 2 and a 4, but it said if they can be reduced, then divide them by their lowest common denominator, multiple, whatever the number, whatever the right math word is. So 2 and 4 is really it's a 1-to-2 ratio, HgO2. Okay, so when in doubt, if it's not something that you know, meaning family 1, family 2, or over here, then the Roman numeral will tell you. Okay, last nugget of stuff. Oh man, this is when you wonder, why would he ever have chosen to teach this class? There are a couple of transition metals that always have the same charge, but don't fit in a column that's always the same. So you need to know this, that silver, always a +1. It always is. Everyone look at where silver is. And this will just drive you nuts. So here's what sucks about chemistry. Silver is always a +1, which would make you think, well, copper and gold are also +1s. But neither one of them are hardly ever +1s. Copper's a 2 usually, and gold a 3 usually. But they can be 1, 2, 3, 1, 2, 3, 4, and only 1. Why? Because whoever invented chemistry had a great sense of humor, like mine. Yes?
How do you get pure gold if gold is reactive? Like,
It's hardly reactive at all. That's why we like gold. All right, all three of those, they're called the noble metals because they don't really react. Now, you can make gold react, but it takes a lot of energy. All right, so silver's one of them. Cadmium is always a +2, and zinc is always a +2. Which would make you really, really, really think mercury is always a +2. But wah, wah, wah. No, it's not. It does what it wants to do. All right. Based on that, you are ready. Go grab an iPad. Don't worry. Any of those messages, just hit cancel or whatever. Don't even worry about them. You're just going to the internet, Safari or wherever you want to try. Doesn't matter to me. And I don't know how good your eyes are, but you're going to type in that internet site at the top. Now, I did not test this on iPads this morning. It may not work, but I think it'll work. ScienceGeek.net/chemistry/tater/unit 2 Ionic Compound Formulas.htm. Have fun. I don't know. Does it link in the PowerPoint? I don't think this is even on the PowerPoint. That link is? One more. No, other way. Right there. It would be right there. The thing that is on here is called the notebook file. It's a little bit different. Is that one dead, Britt? Okay, thank you for plugging it in. Oops, I already have this. I don't know. Oh, I got rid of it, didn't I? Sorry. Well, yeah, but you guys aren't all blessed with amazing eyesight, probably. Anyone have it yet?
It told me it was not fair, but I might have typed it wrong.
Even science geek 404. Don't come back.
Oh, great.
Yeah, you do.
Okay, hold on. I will do it. You'll get a message here in a minute. It'll take a second, but we can figure this out. Come on, baby. You might be able to Google it. I don't know exactly what you should type in. Come on.
Am I supposed to do all 20?
You got there? Yep, just start. All right, so it should go to your messages now. It should pop into all of your messages if you're not there. Maybe. Should be right below the hi. There you go. Okay, you don't have to do all 20. Let's go for 6 or 7 minutes. See how far you get. I'll pull up this thing with charges again. How did it go? Good. Come grab an iPad. The Roman numeral always tells you the positive charge of the metal. Open up the message app and it'll have the link in there, hopefully.